Gentlemen, welcome back to the channel. It's been quite a long time. I'm not dead. I'm still here. I've been working way up north, about an hour north, up in the northern Adirondacks. It's not been fun. You guys probably saw that hotel video that I posted about the hotel and resort. Anyways, we're back here at the homestead, at the house, and I'm down here in the workshop, and I've been trying to figure out what I can do to post something online and share with you guys to show you that I'm still here, that I have not abandoned all of you. I still have the 98 GSX. It's still sitting outside in the driveway, still doing body work. Unfortunately, my whole summer got robbed from me, and now it's starting to snow again. Go figure. But not to worry. We have something we're going to work on today. And this is something that I wanted to post for a long time, but I just wasn't good enough to understand what I wanted to explain to you guys. And I didn't know the right processes yet, but if you can tell what's in front of you, we have our little welding table. We have our Vulcan Pro Tig 205 TIG welding system. We have our bottles, our consumables, some specialty tools. You want to pick up these tools also if you're going to do some of the stuff that I'm doing, and some other stuff that I wanted to go over with you guys. I wanted to share some stuff with you. Basically, all the things that I screwed up on when I bought my first TIG welder. Thanks to all you guys, by the way. I saved 6 months of YouTube money to pay for this thing, so you guys paid for this, so I have to share it with you no matter what. But thank you for that. Let's get into some of this stuff. I wanted to show you guys some of the stuff right here that I used and some of the steps that I've taken to learn some of the processes, like, you know, TIG welding aluminum on AC, doing some mild steel, doing some stainless. Obviously, I'm not a professional, but these are some of the things that I ran into straight out the gate, and some of them caused me a major headache. Like the day that I went and spent all that money on that machine, I didn't have a cart. I had that little tiny bottle of gas. That was stupid. Don't do that. You'll learn more about that later. And some of the consumables for some of the processes. I just don't want you guys to do what I did and end up having to spend an extra $1,000 after you buy your machine and you get some stuff floating around and some parts, and you go to put your first weld down, you realize it sucks, and you find out you're doing something terribly wrong, or you bought the wrong gas, etc., etc. That being said, we're going to just go through some basics here of what I've learned to hopefully save you guys some headache, and we're just going to jump right into it and show you some of the machines, some of the consumables, and what not to do, as well as what worked for me. So hopefully this helps you guys if you're going to go down this path too. And yeah, let's jump right into it. Here we have our Vulcan Pro Tig 205. It's got a nice digital display. It's a pretty heavy machine, and if you go up to Harbor Freight, you can get this thing with a Harbor Freight credit card with like a $200 gift. If you sign up for their credit line, you can get $1,000 plus $200 off your first purchase. So I got this with that, and I used the majority of, like I said, my YouTube money that I made from videos to pay for this thing and pay it off over the last few months. So I own this machine now. Some of the basics that you're going to have to figure out. Step one is going to be figure out exactly what you want to do. So I started with flux core welding. I started with my Chicago electric welder. That thing sucked compared to the titanium brand flux core welder, which I highly recommend if you're going to jump into welding and try something out. Go for the titanium. It's an extra, you know, 50, 60 bucks, but gives you a little bit more control, and it makes some nicer welds. You're going to need yourself a machine. So if you're going to TIG weld, do you want to do stainless? Do you want to do aluminum? Do you want to do mild steel? Do you want to do titanium? What are you after? So if you're going to go for aluminum, you're going to want to have something that does AC TIG. And preferably, you're going to want to have a high frequency start, which means you can push the pedal down, which is over here on the floor above your workpiece, and it will just start the arc. You don't have to start the arc by touching the tungsten to your workpiece, which is called lift, I believe. So lift style, you touch it and lift it up, and then to terminate, you pull it away. I didn't want that. I wanted something that had a high frequency start. So I got this machine right here, and so far I love it. I can't lie to you guys, this thing is fantastic. I got the machine. I got myself a nice auto darkening mask. This is my second one. This is a Miller auto darkening mask. It gives you some settings on the inside. You can do, let's see, you can do weld, cut, and grind. You can adjust the shade, the delay, and the sensitivity in here with those little buttons. It's battery controlled, and it has a little solar array at the top to help charge the battery inside of this thing. You're also going to need some gloves, and you're going to need some filler rod, which I have a few types of filler rods here, and I have a bunch more right up here. Got a 10-pound box right here recently of aluminum, but you're also going to need yourself some gas, and that tank back there is the first big mistake that I made. I didn't buy the big tank. I didn't find a welding supply store. I didn't go out and look very hard. I went to my local Tractor Supply, which, I mean, you can do, but This is what I got first, and it cost me a couple of $100, and it only gives you about a half an hour runtime total, and it's 75-25, so it's 75% argon, 25% CO2. That's not what you want if you're going to do aluminum or stainless or titanium. You want 100% argon. So I went and got myself the bigger bottle, and this is what I use from a welding supply store. All right, so the big mistake, like I said, was buying the little bottle. I'll insert the price of what that little bottle cost. That will work for steel, mild steel, but it will not work that great for stainless at all, and it definitely won't work for aluminum. I went out and I picked up this bigger bottle here, and the regulator that came with the machine was all right, but the first thing that I bought besides the bottle was this regulator right here. This is a ball bearing style regulator. If I kick it on, you'll see it jump up. Yeah, that little steel BB that floats up in there, it kind of tells you exactly how much gas flow you're getting. And I like to run about 10 to 15 CFM if I'm doing aluminum, and then I'll go up to like 20, 25 if I'm doing stainless. So now that we've got that stuff out of the way, this machine right here, you can do DC stick welding. You can also do AC TIG, and you can do DC TIG, and that's what I've been working on lately, is DC for stainless steel. So this is also hooked up, as you see, on 120 volt. It comes with an adapter in the back of the machine, and I'm running 120 to my bench instead of the 220 that I have over here. I like using the 120. I haven't had to use the 220 yet. I haven't welded anything that was so thick or required so much amperage to penetrate. Quite honestly, it works fantastic just plugging to the 120 outlet. So that's your standard household outlet. If you have this thing on a cart, it's sitting outside in the garage, you have to roll it out into the driveway or whatever, you can just throw an extension cord out and you can still weld something with it. The big thing was the bottle. I'm going to say it again. I'm going to stress the bottle. I bought the wrong bottle. Do not waste your money on a micro tiny little bottle and buy a big machine like this, because you're going to burn through gas and you're going to have to go get a refill in your first couple of days of messing around. I used the 100% argon tank for everything. I've used it for some practice on titanium, lots of stainless, and lots of aluminum. It also works on your mild steel. It does all of it. It's a good shielding gas. The next thing that I wanted to talk to you guys about, once you figure out your processes, you figure out what you want to do, which machine you want to get, you got to look at your torch end. So the equipment that they give you in this kit is really good. So this lens right here is not one that comes with the startup kit here. They'll give you some consumables, some basic lenses, some gas lenses, the pink part here, and they'll give you some tungsten. They'll give you 3 different sizes. I forget the exact measurements of the sizes, but they give you a really small one, a medium, and a thicker one. So I like to use the smallest one when I'm working on the majority of the stuff I'm working on, just because I practice on this first. I might move up to the middle size, and I haven't used anything that required the largest thickness in tungsten. And I also have a stubby on here right now too, which is something different. So if you go to Harbor Freight and you need to get another consumables kit, you can buy this kit that they have. It comes with different collets and collet bodies. I've kind of thrown a bunch of tungsten in here, a bunch of different pieces, but it'll give you these little stubby guys right here. It'll give you these shorter collets and collet bodies. And one of the big things that I messed up on was when I originally started, I flipped this collet around in reverse. So instead of it being set like that going in, I had it flipped around backwards, and that blocks your gas flow. Guess how I learned that? So the straight end goes in to the center of the collet and the collet body. Don't do it the way I did it. That'll just make you mad. It made me very frustrated. But this gas lens kit, I think, is like 70 bucks. It comes with a little tube right here of a couple of pieces of tungsten. I usually take my tungstens and cut them into thirds. That way I can use the stubby gas lens kit, because you're gonna basically, you're gonna dip. You're gonna dip a lot. And then when I say dip, I mean you're starting to weld, and you're gonna touch the tungsten tip directly into the puddle, or you're gonna touch the tungsten with the stick, the filler rod, and you're gonna have to stop. You're gonna have to take it back out. You're gonna have to clean it off, grind it again, and then reinstall it. And cutting these things down into thirds, it gives you 3 shots before you have to stop and regrind 3 of them. So if I dip one, I just swap it out for the second one. If I dip the second one, I'll swap it out for the third one. If I dip the third one, I'll go and regrind all 3, and then I have 3 more chances to learn. The welder also comes with this really nice little thickness gauge. So this will tell you the thickness of the material you're working on. It'll tell you what, what you should use for amperage and all that. It's built onto the top of the machine. There's a little chart, so that's nice. So if you're working on something that's, you know, 040, it's 30 to 50 amps right here, it says. If you're on 18 gauge, it's 40 to 70, and this is on aluminum. It gives you a aluminum, a tungsten diameter. All right, so when you get the machine all set up and you put together your torch for the first time, you're gonna end up with a gas lens that looks like this. You're gonna end up with a collet and a collet body that looks something like this right here. So you're gonna have these three pieces, and you're gonna have your tungsten. There's a few different ways that you can sharpen tungsten. Like I said before, I like to cut them down. You can leave it fully sized if you'd like, because this is the back that you would use for the stock machine. If you get the stubby kit, you get this short cap right here, or you even get a smaller one that's like this guy right here, so you can use tiny pieces of tungsten. I've got some stubby lenses, some number 6, number 5, and I think the other one is a number 7 someplace. But all this stuff that you get out of the box will be good for your aluminum. It'll be good for your mild steel. It'll be good for basically those few things right there. Steel, mild steel, doing cast work, a little bit of aluminum work. And if you want to venture over into doing the stainless, this is where I had a massive hiccup. So I wanted to try to do the stainless, but I couldn't figure out what I needed to do stainless correctly. I looked online, I couldn't figure it out. I was trying to research it, and there wasn't very good information on why my stainless was coming out so terrible. So basically, stainless, you want it to come out nice and shiny once you weld it, and you don't want to have ugly spots on it. Actually, I think I have some practice metal right over here I can show you. Yeah, all right, so right here, we have some practice. Just some first couple passes of stainless right here. So you see the colors that you get here. This stuff right here, I was having a really hard time getting anything to come out with this kind of color around it. So basically, you want a nice heat effect zone. You see how it's nice and even along here? My heat effect zone, where the edges of the weld, you can see it's like a bubble around the weld itself. It was getting really wide. So I was putting too much heat inside of this piece. And this is thin metal, right? And it wasn't giving me a good color. It all looked like the backside here. It all looked crappy. It was all brown and discolored and gray, and it just looked like crap. And that's not what you want. You want your stuff to look nice and shiny and rainbow. You can see this one was pretty hot in the front. I was going too slow, and then I started to pick up the speed, and then everything kind of squared up a little bit. But some of them I figured out did okay. Some of them I definitely did not. Problem here was that I did not have the correct type of gas lens. So I started searching. I couldn't find a real definitive answer. I was just looking everywhere I could, and it took me going on to I think it was Pacific Arc Tig Welding. That channel's fantastic. Weld.com, the fabrication series. I watched hours and hours and hours of those guys' videos, and the thing that kind of taught me what I needed to do, it was I needed to get a bigger cup. I needed a bigger lens. So I got a number 16 lens, and that's what allowed me with the small tungsten to make these little starter welds here and make something that looked somewhat normal to what I was trying to aim for. If you compare the two of these, you can see stainless, titanium, all that requires so much additional gas flow. So you're getting this nice color from the amount of gas, the shielding gas around it. It's a combination of, you know, your amperage, your DC electronegative settings, your speed and your rate you're going forward, your dab rate, all that. I mean, a bunch of stuff ties into this, so I'm probably misspeaking to some degree, but I learned that this tiny little lens wouldn't give me this. It would just give me something nasty looking, something black, something, you know, you want to retain that stainless steel look and that stainless ability of the metal. You don't want it to corrode up or look like crap once you're done welding it. You want it to remain stainless. Well, you can't do that with one of these lenses. So I looked online, I hunted around, and I saw, I believe it was the fabrication series sent me to a website, to one of their links. It's called the Furick Cup, F-U-R-I-C-K cup, like furickcup.com. They have you know, the Pyrex clear glass lenses. They have ceramic lenses, and I found these ones on Amazon. It came with the one I'm using right there, the 16, the 14. What else do I got? A 12. And I got one big dog right here, which is a 24. So that's a monster lens. And all these are on Amazon for like 20 something dollars. The single glass ferret cup I think was like 50. So I tried these first, and so far for the last 4 or 5 months I've been using these. I haven't used this yet. I feel like I should try it, but they basically disperse a larger plume of shielding gas over the piece that you're welding on. So as you're dabbing and you're moving along, this just shields it a little bit longer and protects that metal while it cools, so it doesn't oxidize and leave some ugly, nasty looking black welds or gray welds or just mess up your part. I wish I knew this stuff in the beginning, but it seems like no matter what I do when I search these videos and search these processes online, if you don't actually specifically look at what the guy who is explaining some of the stuff is using, you're not going to figure it out. And you're not going to figure it out in the beginning because you don't know what the heck you're looking at. But I'll tell you one thing, doing the aluminum welding versus going over to stainless steel TIG, aluminum is 1000% easier than the stainless steel. I've made some practice pieces here from some scrap. This right here, they call them coupons, for those of you who don't know. You get these little pieces of a decent thickness of aluminum, and you basically just overlay them, and you just do little fill-in welds. I think they're called fillet welds. So just go and you practice. So you put these pieces together, and you start welding them together, and you work your way down. And we're gonna mess around and do some of those here shortly. But before we get too far into that, we've got to discuss some of the necessary tools that you guys might want to have around here. Alright boys, so now you have some of the stuff that you need to start welding here. And like I said, we're going to work on some aluminum TIG for a few minutes. Just do a couple of quick test passes. You're going to want to figure out how to sharpen your tungsten. And there's a bunch of different ways. You can buy an expensive tungsten grinder that will sharpen it perfectly, which I totally agree with. That's definitely the best way to go. And there's some other ways you can do it too. So what I like to use is my good old-fashioned drill, and I like to grab an angle grinder like this right here, and I only use a specific one, this pad right here. It's a 36, I believe, no, 29 grit. I like to use this, and then at the end I like to use a piece of 600 grit sandpaper to smooth it out if I need to, but most of the time this combined with that drill will do the trick. So what you do is you go over to your torch here, and all you have to do is unscrew this back cap, and then you can pull out your piece of tungsten. This is the 1/16, I believe, and you fit this thing right into the chuck of your drill. Make sure it's nice and straight so when you hit the button on your drill, it doesn't go wobbling all over the place. You come over here to your angle grinder, and I'll show you right now. You're just going to fire it up real fast, and you're going to run this on the edge of it. This grinder is going to spin in a counterclockwise motion like this, and I'm going to lay this here while running the drill at the same time, nice and slow, at about a 45-degree angle. And this gives you a relatively nice little straight tungsten. It's got a nice edge on it, and that's what we're going to use to start welding our aluminum coupon here. Okay, so now that we have our tungsten nice and sharp, we've got it sticking out the front of this, I believe this is a number 6 gas lens right here. We're going to make sure our gas is turned on and set to about, I don't know, we'll call it 10 to 15 CFM, and you can test that by looking at your lens or your gauge and tapping your pedal. So that's pretty high. So we're at like 28. We're going to turn that down just a touch. And that beats floating right there. We're about 15 CFM. We're going to say that's good enough. We're going to take our number 16 cup right here, stash it in our consumables kit, and we're going to leave that off to the side for now. And some of the other things that you guys might want to have on hand if you're going to be taking scrap metal like I did and making little pieces of aluminum out of them, or little pieces of pipe. I have a sheet metal bender over here that I got from Harbor Freight. I think it was like 80 bucks. I've got a nice little bench top belt sander. This is fantastic for doing edges, cleaning up box corners, whatever you're working on. This thing helps a ton. You want to have yourself an angle grinder, maybe a drill. This little 3/8 die grinder is fantastic for removing inside corners when you're doing welding and you have like a fat part on the inside of the corner of a box or something. Definitely helps a lot to have some of these tools. And this cutter right down here, like a bandsaw right here. It has a nice blade from Harbor Freight. It's a Bauer. It was not too cheap, but it's worked a lot. It's done a lot of really good work. We're also going to use ourselves some magnets here to find our corners, some clamps for our fixture table right here. This is just a cheap Harbor Freight style fixture table. Gives you a nice right angle here. These little wings go up and down. Clamps and a triangle. So you have a bunch of stuff sitting around here. First thing you're going to want to do is figure out which two pieces of metal you're going to put together. And before you even start, you're going to want to clean these bad boys off. And I like to use either a combination of my angle grinder to clean off any scale or roughness that may be on it, coupled with some 99% isopropyl alcohol. So I'll spray the parts off, get them nice and cleaned off once I get all the debris off of them so they're decent looking. And then what we can do is clamp them down in the position that we want them to be clamped in, using our little clamps right here. And I hook the grounding clamp up to the side of the table, and I just have a set of vice grips right here holding my torch in the corner up there. But now we're going to go ahead and clean this stuff off real fast. This machine, once you set these clamps up, you don't ever have to mess with the settings for the clamps as far as like swapping them back and forth goes. Your foot pedal goes in the center, you got your ground, and you got your positive. All you have to do is click the process button right here, and it's on DC right now. Hit it one more time, it goes to DC stick, and then hit it again, it goes to AC TIG. We're at 80 amps, so we're going to drop that down to, we'll start at like, I don't know, we'll do a test pass at 60 amps, and my parameters, I like to do a half a second of pre-flow, and then hertz. The more hertz I found, the higher the hertz go. This goes up to 160, I believe, yep. So I leave it around 100 to 115, so we'll go 115 right here. We're going to leave ourselves at 70% electrode negative, 30% positive at 60 amps, and we're going to run a test pass on a piece of this metal here. We have one oddball piece. I like to do pairs, so I have two pieces here, I have two pieces here. We're going to use this oddball as our test piece. So we're going to test on this first, then what we're going to do is weld this piece and this piece together. My test piece right here, and I'm going to practice on this first just to make sure that whatever my settings are, like I said, I'm at 60 amps right now on my machine, and I've got about 15 CFM of gas flow on a number 6 cup, and I've got about, we'll call it a 1/4 inch or so of stick out right here, which is as far out as the tungsten pokes from the edge of the cup here from the gas lens. So it kind of goes without saying, if you start to lay a weld down and something's not correct, or you don't feel like you're hot enough, or you don't have enough amps, turn the amps up. If you have to switch up to the next size tungsten because you're balling up the end of the tungsten real bad, or you're melting it or cooking it apart, get the next size tungsten, change the inside of the guts out, the collet and the collet body out, put the same lens back on, tighten her down. Looking at this, you can see we got a lot better result on that second pass there. It looks like we're still pretty cold, so we're going to bump the amps up just a little bit more. And you have to remember, while you're testing, this part's going to get hot, and once the part gets hot, it's going to be easier to melt every single time you test, so make sure you're paying attention to that. So I'm going to get after that right now. That actually looks a lot better than I thought it would, so we're going to probably knock it back down to 65 amps just because it's kind of hot. Once we introduce that filler metal, it should hopefully knock down some of the temp that we're seeing right here. I kind of straight off to the edge there, but we're going to try to go straight across just below the center line here, about to the halfway point with some of our filler rod, and see what happens. All right, so looking right here, I'm sure I could adjust this just a bit more and make it look even better. But we have some decent little dimes going down right here. I'm sure I could mess with the settings just a touch more, make it a little bit better, maybe change the hertz. And these are kind of bumpy, so it could use probably, I'd say, a little bit slower. If I were to slow down some and then maybe pick up the amperage if I'm going at the same pace, we'd have a really good looking weld. But we're gonna go ahead and try to put our two pieces together that we cleaned right over here and see what we have. So now I have a couple of pieces of this aluminum right here, and I have some rod right here, some 4043, and I have another type over here. I use the 4043 versus the, let me see, the ER 5356. I find that the 4043 goes basically into every piece of aluminum that I practice on. So we're gonna go here and we're gonna join these two pieces of aluminum. There are two separate plates right here, as you can see, and we're just gonna go through, and we're at 150 hertz at 55 amps with 7030 on DCEM setting, and I'm using the middle-sized piece of tungsten. Obviously, I forget this all the time what the sizes are. But anyways, there's three: small, medium, and large. I'm using the medium. So we're gonna go ahead and slap this together with a piece of that rod right there, and I think it's 1/8 inch rod, and then you have 1/16 also. I have some 16th inch 4043, but I'm gonna use the 1/8, and we're gonna join this together right here. Nice slow pass, and hopefully it goes together nice and easy. So now my part is stuck together. I'm gonna go ahead and fill it in with some of this 4043 rod, and hopefully it looks all right. We'll see. All right, we've joined our part together. Not the prettiest welds, but again, I'm still learning. I have some settings adjustments that I have to do, and the shinier you get it, the better. Obviously, these look kind of dull. There's some settings that I have to mess with, but this part is together. It didn't burn through. It's nice and solid. This is what I was working on with my intercooler piping. So that's our aluminum piece right here, and now what we're going to do is we're going to mess around with some stainless. And like I told you guys earlier, the stainless is all about the gas coverage. Right here in this torch is number 6. If we want, you can go bigger all the way up to this big dog, this number 24, which, I mean, look at the difference there. You can see one's a monster. But the big thing here is allowing gas coverage for the stainless. You don't want the stainless to get oxidized by the oxygen in the atmosphere here. So we want to protect it as long as we can, so we're going to use a lower amperage setting, and you can use pulse if you want. This machine has pulse. We're not going to get into that today. I'm just kind of giving you guys a rough idea of what's going on here with some of the stuff that I've learned, and show you hopefully how to get started, because it took me a lot of trial and error to get this thing up and running correctly. I thought it would be a quick plug it in, use some of the info I found online, and I'd be making some welds, but I was very, very wrong. Alright boys, so we've gone through some aluminum stuff, we've gone through the basic settings that I use for this machine right here. Obviously don't buy yourself a little tiny bottle of gas. Obviously I'm not that great at doing the stainless yet, but I'm starting to figure it out. I'm still working on my settings, my pulse settings, all that fun. But the aluminum stuff, I mean, if you're going to weld some pieces together, you can make it happen right here. Thanks for following along. It's been fun. We're going to keep learning how to weld. We're going to keep making some cool stuff. And as time passes, hopefully my skills get a little bit better, and if you guys are following along with me, your skills get better too. So if you have any questions, make sure you drop down below. Shoot me an email at todaysprojectguide@gmail.com. Follow me on Instagram, TikTok, all the fun places. Hit me on Threads if you want to, or email me directly if you have some questions. Anyways boys, it's been a blast. Can't wait to see you in the next one. Take care.